Hi guys, Ms. Cronin here. In this video I'm going to do some examples on how to solve a quadratic by completing the square. We'll look at a couple of different scenarios and what you have to do in those cases. So what I'd like you to do for each of these problems is pause and write the problem down, and then pause as you're going along as much as you need to. Write the examples down with me though. Okay, so for this first example, we want to get the x terms. We're going to isolate the x terms, so we're going to add 7 to both sides. So on the left side over here, if I add 7 to -7, it's going to be adding to 0. And if I add 7 to 0, I get 7. Then the next thing we're going to do is we are going to complete the square. So I want you to think to yourself what you would have to add here. And you have to do the same thing to the other side as well. So when you complete the square, you're going to take half of the b value, which is 2, and then you square that result. So 2 divided by 2 is 1, 1 squared is 1. So we are going to add 1. If I add 1 to that side, I have to add 1 to the right side as well to keep this equation balanced. Then we completed the square in order to create what's called a perfect square trinomial, which is this thing right here. Every time we complete the square, if we did it correctly, we're going to have a perfect square trinomial. Trinomial meaning 3 terms. And the perfect square part allows us to factor this easily. If you think about how this would factor, it's going to factor into x plus 1 squared, because you have to multiply. Just show it over here. If I just factor this, it's x, and then factors of 1 is 1 and 1, and they have to add to 2, which they do. But whenever you have a perfect square trinomial, it'll always factor into x plus half of that number, that b value, 2 squared. And then on this side I have an 8. And now we have what we were working on in 2.4 part 1. We're going to take the square root of both sides. And on the right side, don't forget to do plus or minus. And one sec here. Write these notes down. They'd be good for you to follow. When I take the square root of a quantity squared, the square root and the squaring cancel each other out. And on this side I have plus or minus the square root of 8. Now, that has a perfect square in it of 4. So I'm going to split that up and write the square root of 4 times the square root of 2. And kind of do 2 steps at once, because now I'm also going to subtract 1 from both sides. So I get x equals -1 plus or minus. And the reason I split 8 into 4 and 2 is because the square root of 4 is a perfect square. 4 is a perfect square, and so when I take its square root, I get a nice whole number here of 2. So the answer to this problem is x equals -1 plus or minus 2 times the square root of 2. All right. This next example requires that we rearrange some things first, because it's not in that form. We don't have our x terms on the same side. So I'm going to subtract 12 from both sides, and I'm going to add 8x in a second here. You can do both things at once if you want to, but I'm going to subtract 8x. Did I say add? I think I said add. And so on this side I have -12, and on the other side I have x squared minus 8x. So I just moved the terms around, rearranged it so that I have my x terms on the same side. And this also involves completing the square when my b value is negative. So if you have a negative b value, how does that affect this? And we'll look at that in a second here. All right, so I have, I didn't write my equal sign there, -12 equals x squared minus 8x. Now I'm going to complete the square. Why don't you guys do that on this side, on the right side this time? Doesn't matter if the x terms are on the right or on the left. Think about what you would have to add. So you're going to take half of b, and b is a negative 8 divided by 2, and we're going to square that. That's negative 4 squared, which is positive 16. So I'm going to add 16, and I have to add 16 over here as well. So on the right side, I made that into a perfect square trinomial. And this time, so what happens every time so far when we've done these problems in class as well, we take x plus half of b, and b is a negative 8, so it's actually going to end up being x minus 4 squared. So if the b value is negative, then when you factor it, it's going to factor into x minus whatever half of b is. And on the left side, I have a 4. Now I'm going to do the square root, and I have to do plus or minus the square root of 4. So that is plus or minus 2. And the square root of this quantity squared cancels out. So I have plus or minus 2 equals x minus 4. If you don't like having it switched like that, you can always put the x terms on the left side because that's how we're used to doing it. And when I add 4 over here, I'm going to get 4 plus or minus 2 equals x, because this side minus 4 plus 4 is 0. And my two x values, one of them is 4 plus 2, the other one is 4 minus 2, so we get 6 for one answer and 2 for the other. Okay. Okay, go ahead and pause, write the problem down. Notice that this time we have a negative, or not a negative, we have a positive b value, but it's odd, which makes it just a little bit more challenging because you have to work with fractions, but you'll see. So step 1, add 5 to both sides. We get our we isolate our x terms, leave room to complete the square. So my b value is 3. You do the same thing. You take half of b, half of 3 squared is square the fraction. So 3 squared is 9 and 2 squared is 4. So we're going to add 9/4. So we have to add 9/4 over here. And I'm going to turn that 5 into a fraction by putting it over 1. And I'm going to need to find a common denominator, which is 4. So, and this side is still going to factor into x plus half of the b value. This number that goes here is always half of the b value. And then, so if it's an odd, that's really challenging to factor, but if you realize that you've created a perfect square trinomial, which always factors into x plus, or if it's minus, x plus half of the b value. This is what it will always factor into. And then I have 4/5, 4 times 5, which is 20, over 4, plus 9 over 4, so 29 over 4. We're going to take the square root to get rid of the squaring. Take the square root of this side and do plus or minus. Moving over here, I have x plus 3/2 equals plus or minus. I'm going to split the quotient up, square root of 29 over square root of 4. And the square root of 4 is 2, so I can write that. Plus or minus the square root of 29 over 2. And then I'm going to subtract 3/2 from both sides. So I get x equals negative 3/2. If I'm subtracting it, then it's going to be negative on the other side. Plus or minus the square root of 29 over 2. And since the square root of 29 is prime, or 29 is prime, I'm going to just leave negative 3 plus or minus the square root of 29 over 2 as my final answer. There we go. Okay. And so this last example has a lead coefficient that is not equal to 1. And there's a couple of different ways to work through this. One, you can just start out by dividing by that lead coefficient of 3. And when you do that, you have to do it to all of the terms. So here, it's x squared plus 2x equals, leave some room to complete the square, equals 1/3. When you complete the square, take half of b and square it. And add that to both sides. So 2 divided by 2 is 1. 1 squared is 1. So we're adding 1, adding 1. Since it's a fraction, I'm going to put 1 over 1. So I'm going to want to combine those in a minute. This factors into x plus half of that b value squared. So x plus half of 2, which is, notice it's always the number that got squared over here. And multiply by 3, so we have a common denominator. I get 1 plus 3, which is 4/3. And then take the square root of both sides, plus or minus on that side. So x plus 1 equals plus or minus the square root of 4 over the square root of 3. And then subtract 1 from both sides, and you get -1 plus or minus the square root of 4 is 2, and then I have it over the square root of 3. And that answer is just fine, except for usually what we do is we try to rationalize the denominator when you have a square root in the denominator. And you do that by multiplying by the square root of 3 on the top and on the bottom. And so we get x equals -1 plus or minus 2 times the square root of 3 over the square root of 3 times the square root of 3, which is just 3. And that would be your answer. You could also find a common denominator for the -1 and add them together, but this is fine. Okay, in this last example, it's the same as the one previously, but I'm going to show you a different way to do this. One thing you could do, instead of dividing everything by 3, is we can factor out a 3 and leave a space to complete the square. Now, when you complete the square, just ignore the 3 for a minute, and you're going to add half of 2 squared, which is 1. But the 1 gets multiplied by the 3, so you're going to add 3 to this side. Thank you. And then this becomes 3 times x plus 1 squared equals 4, and then divided by 3. And I get x plus 1 squared equals 4/3. And then it looks like the problem we had from before. Take the square root of both sides, you get x plus 1, not x plus 2. Taking the square root, plus or minus. To get x plus 1 equals plus or minus the square root of 4 over the square root of 3. And you can see that we get the exact same result. That's 2 over the square root of 3 as before. And I'm going to still rationalize here. And that becomes -1 plus or minus 2 square root of 3 over 3. Either way you do it is fine, and in fact, your book shows you even another way to do it. But I'm just going to show you these 2 ways. If it's not working for you, let me know. I can show you some other alternative methods, but hopefully this will help out. All right, adios.